Hello and welcome to the Kevin P. Granata Biomechanics Lab Tour. I'm Dr. Sarah Rena. I'm a Collegiate Associate Professor in the Biomedical Engineering and Mechanics Department and the Interim Program Chair for the Undergraduate BME program. I am one of the collaborators in the Kevin P. Granata Biomechanics Lab that is led by the PI, Dr. Robin Queen. And we have some students here with us today as well, some undergraduate and graduate students. So I'll go ahead and let them each introduce themselves.
Hi, I'm Michael Teeter. I'm a first-year PhD student in biomedical engineering and the Granata Lab.
Hi, I'm Riley Hatfield. I'm a junior in biological systems engineering, and this is my second semester working in the Granata Lab.
I'm John Paul Williams, and I'm an undergrad junior, and I'm mechanical engineering, and this is also my second semester in the lab.
Hi everyone, my name is Sarah. I'm a senior in mechanical engineering, and I'm an accelerated master's student in the biomechanics lab.
And all of us are actually in our own room and space. So now we're going to go ahead and take our masks off so it's a little bit easier to talk. So what we are going to do now is show you a couple of videos that have been created showcasing the lab.
So we're focused on understanding both injury prevention and then recovery, mostly in the orthopedics realm, trying to understand both our young athletes as well as our older adults and how we can get them back to doing the things that they love to do. We're working on direct engagement with our clinicians and our clinical faculty to try and translate the work that we do here in the lab out into the clinic setting.
A lot of the injuries that we're working on helping people recover from has taken them out of their sport for 6 to 12 months at a time. And so these are very frustrated individuals who are very eager to get back into playing sport. However, their high risk for injury is a really big problem. So trying to help them reduce that risk for re-injury is very important.
I really love how interdisciplinary the research is. I've had opportunities to work with people both within and outside of my discipline. So really getting to know how to work with different people from different spaces on lots of different projects has been a really cool experience as a grad student.
Some other aspects that we're going to show you are the different equipment that we use in the lab. The first ones that we're going to talk about are the force plates. So the force plates are ways that we can measure how our feet or any body part is interacting with the ground. And it shows us how much force we're applying and what direction it's being applied.
Hi, my name is John Paul Williams, and I'm an undergrad research assistant with the Kevin P. Granata Lab here at Virginia Tech. And I'm going to tell you about how we use force plates. In both our treadmill lab and our main lab, we have embedded force plates that allow us to gather valuable data. The force plates gather data called ground reaction forces. This data allows us to understand how much a person is applying with force under each foot when pushing off the ground as they walk, run, or jump. When a person applies force to the force plate, it sends a signal to the system, and the ground reaction force is displayed on the computer screen for the researchers to use. It shows the magnitude and the direction of the force. A good example of how we use the force plates in the lab is by having a participant walk from one end of the room to the other, passing over 4 plates aligned in the center of the lab. As the participants walk over the force plates, the force they are applying is sent to the computer and observed by the researcher. On the computer screen, the force is shown by an arrow. The bigger the arrow, the bigger the force. In the direction of the arrow is pointed shows the direction of the force, generally progressing in the direction as the participant passes over the plate. After the researchers have gathered all of this data, the data is processed and analyzed, and we determine many things about the participants from this data. An important measurement we can gather from these forces is the asymmetry of a person's gait, or balance. This means we can see if a participant's left or right foot are applying the same amount of force. The more similar the left and the right side are to each other, the more symmetrical their gait or balance. If the right and the left have big differences, asymmetries can be identified, possibly related to an injury or as a sign for an injury risk. This assessment can lead to researchers in answering questions related to helping doctors and future researchers in promoting a quicker recovery or injury prevention. Thank you.
So the next thing that we're going to kind of pull up is to show you kind of an immersive environment. So within that space where we had the 3D where we had the force plates, is we were able to take 3D cameras. So this is as if you were standing on the force plates, and you can kind of look around the room here. You can see the force plates are underneath of us, as well as there's many of these cameras oriented around the room. So what these cameras do is they actually emit infrared light, and we place reflective markers on our participants, so little silver balls that the light reflects off of and goes back to the camera to give positions. So that's one of the ways that we can look at movement at the same time as we're looking at the force being applied to the ground. So, and here's our data collection hub. So this is where our researcher sits, and we can display live feedback to the participant for various studies. So for example, if we're looking at biofeedback, we can give a particular movement that the participant is doing, showcase it on the screen, and kind of give them a visual on how they can move or change towards a specific goal. The other space that we're going to show you is the treadmill lab. So the treadmill lab, this is again another immersive picture, is very similar to what we just showed you. So that was kind of more open walkway area. This one is where we have an instrumented treadmill. So there's actually force plates within this treadmill. And it also has the motion capture cameras up here as well. So we can again collect movement information as well as the force that's being applied. You also see our nice changing hub for individuals who come and participate. Oops. And you can see the camera tripod. All right, so the next thing we're going to show you is the treadmill.
An instrumented treadmill is a useful instrument used in biomechanics. The device is able to collect and store forces applied by each step a subject takes. Forces created by each step are called ground reaction forces. The treadmill is structured so that it sits on force transducers. Force transducers convert mechanical energy into electrical energy, allowing for data to be easily accessible. Here in the Granata lab, we use vertically aligned force plates that allow for more accurate readings of each step. A primary benefit of instrumented treadmills is that steps are able to be recorded continuously as the subject remains in the same location throughout the trial. Instrumented treadmills have a variety of uses in biomechanics field of study. One of the applications that we have used it for in the Granata lab is to receive biofeedback on patients that have undergone a knee replacement. Knee replacements can make it very difficult to perform basic daily activities such as walking and moving around. Studying the post-operative recovery period is important in order to provide the best possible rehabilitation to help patients walk similar to their healthy peers. Some studies might need to simulate different scenarios like walking up hills, which is why the device is capable of changing the inclination as well as speed. Recovery plays a vital role in the process needed to regain health and return to a normal lifestyle.
All right, and so one more video that we're going to talk about. One of the main focuses of the Kevin B. Granata Biomechanics Lab is looking at symmetry across different tasks.
Hello, and welcome to the Granata Lab. My name is Julia, and Adam here is going to demonstrate landing from a jump. After each landing, we will have you determine whether Adam landed symmetrical or not. If both feet look like they landed similarly, then the landing was symmetrical. If one foot looks like landed harder than the other, then the landing was asymmetrical. We will play each clip twice and give you some time to think about if the landing was asymmetrical or symmetrical. After this, we will then show you data from our load cell, which demonstrates loading symmetry to determine if the landing was actually symmetrical or asymmetrical. From looking at this video, do you think the landing was symmetrical or asymmetrical? If it was asymmetrical, which foot landed the hardest? I'll play it again for you. If you guessed that this landing was asymmetrical, you are correct. As you can see from the load cell data, the left foot in red produced a higher amount of force than the right foot in blue. Now I'll show you another trial. From looking at this video, do you think the landing was symmetrical or asymmetrical? If it was asymmetrical, which foot landed the hardest? I'll play it again for you. If you guessed that this landing was asymmetrical, you are correct. As you can see from the load cell data, the right foot in blue produced a higher amount of force than the left foot in red. Now I will show you the last trial we have for today. From looking at this video, do you think the landing was symmetrical or asymmetrical? If it was asymmetrical, which foot landed the hardest? I'll play it again for you. If you guessed that this landing was symmetrical, you are correct. As you can see from the load cell data, the left and right foot produced almost equal amounts of force. So you may be wondering, why do we care about symmetry? Well, vertical ground reaction force asymmetry is significantly associated with knee extension moment asymmetry, which is an indicator of injury risk in athletes. Basically, the more asymmetric you are, the higher chance there is of injury. We have covered a lot for today. There's a lot more to see on the rest of the NBD website. Have a great day!
So the load cells are instrumented foot inserts that go into the shoe. So on our mock participant, you can see the little bit of the electronics that are kind of coming out. So these lay flat in the bottom of the shoe, and they act very similar to force plates, but they allow us to see the pressure distribution across the bottom of the foot. So specifically, the load sole lets us see certain parts of the foot, whereas there's another one called pedar that allows us to see really across the entire foot. And so it lets us look at the force that's acting within the shoe as we do different movements. So these are really great to use in the field or when we're trying to work in real person environments, as well as we do a lot as well with high-speed camera videos to really be able to get into clinical and athletic environments. So the last video that we're going to show is for fun. Pull it up. And this was created by our students in the lab. It's one of our TikTok videos looking at using our load soles, which is on the bottom here, in one of our students, as well as the marker data that's being collected while they do their dance.
I'm running out of time.
All right. So we thought we would next, after kind of showing you the different equipment that we have available in the lab, we'll have each of our students talk a little bit about the projects that they are currently working on, and then kind of open it up for Q&A. So let's see. Riley, would you like to go first?
Yeah, sure. So the stuff I'm working on right now is, like you all saw in the Symmetry video, knee moment extension asymmetry can cause a lot of re-injuries in ACL patients. And typically how we measure that is using the force plates and the 3D motion analysis and all that expensive and kind of confusing equipment. So I'm working on basically trying to determine if patients or if players and people who are injured ACL injuries can return to play, basing it off of the load sole data that you also saw in the video, measuring based on the load sole data.
See, and up next we'll have Sarah.
So I've been in two major spaces in the lab. I've been in, again, the asymmetry realm and also working a lot with sensors. So in asymmetry, one of my projects was focused on looking at how asymmetry changes between and across tasks. So a lot of times we kind of focus on one task in particular and not really pay attention to how it compares as you move from like a easier task to a harder task. So I've been working on seeing if there are any differences to how your limbs control posture and stability across tasks. And then in the sensors realm, I've been working on either using the sensor data, which is mostly either going to be acceleration data or gyroscope data or angular velocity data to get to foot clearance, which is a measure like a position of the foot and how the foot kind of clears either just as you walk or how it clears an obstacle. And I've also used it to get other gait metrics such as step length and stride time. And also I try to use that in kind of quantifying balance and seeing how a sensor compares to our golden standard or the motion capture system and quantifying balance.
Thank you. Let's see, John Paul, we'll have you go next.
Okay, so the project I'm working on right now is it uses the intermittent treadmill that we showed in the videos, and also uses the load cell that we kind of showed. And we're using those to compare asymmetry and like step count and different things that we can't calculate in the lab, and then comparing it against the iPhone's health app, and be able to see if this health app is actually calculating things like accurately and like giving you a good description of like what these values are for yourself.
Thank you. And Michael.
Yeah, so the major project I'm working on right now uses the force plates and the motion capture system. And we're comparing a group who has undergone ACL reconstruction and a control group. And we're looking at symmetry differences during a stop jump. So this is where they'll start back from the force plate, run forward, jump off one foot, and try to land as, symmetrical as it can on 2 feet or 2 legs. And so what we're expecting is this ACLR group to have more of an asymmetrical landing, specifically with a limb stiffness measure. And this is calculated taking the maximum ground reaction force over the displacement of the center of mass. So what we expected to see was the ACLR group have more asymmetry, which would put them at a higher risk for a secondary ACL injury compared to the control group landing more symmetrically.
Perfect. Thank you. So right now we'll open it up to Q&A, but really quick, I would like to talk a little bit about our undergraduate involvement in labs. So specifically in the Granata Biomechanics lab, as you can tell, we have 3 undergraduates here who are working on projects. We do tend to recruit a lot of undergraduate volunteers in the lab for various aspects, and we recruit from across different majors, but we also have a biomedical engineering undergraduate major.
Some other sessions with the engineering program open house talked about co-ops. Are there opportunities like that with biomechanics?
I would say there definitely are. We are actually working on a program right now where we have a professional development course that kind of funnels into some select co-ops that are associated with our biomedical engineering program. So that we have a specific kind of co-op program that we're working on, as well as all engineering students have the opportunity to co-op, just kind of depending upon what you find and what you like to do. Specifically in biomechanics, there are some options such as co-oping with a sports industry like Nike. Does a lot of motion capture analysis kind of related to what we do, but there's also other aspects of biomechanics, such as working with medical device development and looking at material selection and so forth with W.L. Gore, Medtronic, Johnson & Johnson, and so forth. So there's a lot of options for co-ops as well as internships if you don't want to co-op during the semester.
So for those that are undergrads at Virginia Tech, can you tell us sort of one thing that your favorite thing about being a Hokie, the thing that you love about Blacksburg or about being on the Virginia Tech campus?
The food. It's too good. The food on campus is insane. It's some of the best stuff. And I'm currently an off-campus student. So last semester off-campus student who didn't have a meal plan weren't allowed, obviously because of COVID and stuff. So I missed it a lot. So please and try our food. It's great.
I definitely say the same for me. Like, food's amazing, but also like being in the middle of the mountains is one of the reasons I came here, and just like being able to like be within 5 minutes of some amazing views, and also being able to like get 30 to 40 minutes to some amazing hikes and stuff. It's been great to be able to like have those things available on the weekends.
I would say probably the community. I grew up in Roanoke, so I've kind of been here my whole life. But I just think the teachers and the professors are awesome, and it doesn't matter that it's a big school. I still feel like I know a lot of my professors really well. I think they do a great job of that here at Virginia Tech, and I just love the community. If you're a Hokie, you're a diehard Hokie, and that's that.
So speaking of food, what are your favorite places to eat? For those that are foodies here on campus.
That's a really hard one. So on campus, I would say There's a place called Turner's Hall, or it's in Lavery Hall, and it's called Turner's Dining Place. And they have a lot of different cuisines, but they have a place called Origami, and they serve like Japanese cuisine. Their fried rice is incredible. I would definitely try that. And then off campus, there's way too many to choose from. But my favorite place would be, I think, Greens, because they do both sushi and kind of Mediterranean, Middle Eastern type things. Yep, bit of Greens.
Yeah, I second that. On campus, I would definitely say Turner's. I actually live on campus. I'm in a sorority house on Oak Lane, which is like a mile kind of off campus. But I walk to Jamba every morning and get a smoothie. And then off campus, I would probably say El Rod's is what we call El Rodeo here. I'm a regular, so love that place.
I would say for me on campus, like when I was a freshman and sophomore, when I was still on campus, it was definitely D2. I was definitely a regular at D2, going there at like 9 a.m. and then staying till like 3 p.m., knocking out homework, but also eating. It's like all to eat. So you just keep eating, but also knocking out homework. And then off campus, shoot, there's a lot of good places. I guess depending on, like, if it's like breakfast, maybe a little partial since I used to work there, but Joe's Diner is really good for breakfast. And then Sharky's for like just like wings and burgers and stuff. I really enjoy there.
I didn't get to experience any of this on-campus dining because it's my first semester here and grad student. But yeah, for off-campus, I've gone to Cabo Fish Taco, which is really good. And like the name says, they have a lot of seafood options for their tacos. But yeah, the portion size is huge. It was just really good. I kind of blew me out of the water. And that was like one of my first meals here. Another good place was 622 North. It's got a lot of options as well. I would say it has like the dining area and then like a bar area attached to it, but like for like the sit down dining, it's a little bit fancier. But yeah, the options there, it was very tasty. So I would recommend it.
You talked a little bit, John Paul talked a little bit about the things he loves to do outdoors. So talk to everybody about things that you do for fun. I know this may be slightly different in the COVID realm we're in right now, but if you can give us your thoughts on kind of before or now, and maybe they're the same, the things you really enjoy doing outside of your coursework as part of the Hokie community.
I can start it off. And so, like, some of the things I like to do, so I'm a part of the running club here at Tech. And so, like, we get together on the weekdays and go on runs. And so we're also, like, a competitive, like, cross-country and track team. And so, like, almost like what club is that, like, being able to, like, be part of that club has been nice to be able to keep the competitive aspect up, but also be able to be in shape at the same time. Get to explore a lot of Blacksburg by doing that. And then like to go on hikes, but and then also one of the things that I'm excited for to come back is be able to like attend sporting events. It's like football season is one of the best times of the year. Get to go out there and be with 60,000 other Hokies screaming and yelling and going crazy with the football, like watching the football game. And then same with basketball. And all those sporting events I enjoy being able to go watch.
Something I got involved in starting my freshman year was the sports medicine club, and through that I've been a full-time student trainer with the men's soccer team. So I get to travel with them. I go to all their practices. I do like rehab and physical therapy appointments with them. So I've learned a lot through that. And then it's really cool also to like integrate that into the Granata lab because I get to study that type of thing too. So that takes up a lot of my time outside of school, but I love it.
So from freshman year to junior year, I was part of the Alopecia Living Learning community. So that's a community of just engineering students all living together in the same space. And that was really cool because you also get to sit through a class freshman year. It's kind of a free A, but it teaches you a lot. Like some of the stuff that I've done in that class, like writing a cover letter and learning how to, give an elevator pitch or resume and stuff. Some of that I still do to this day, and I use the same cover letter that I did with updates, but like the same skill that I learned, I apply now. And it was a really nice environment to be part of because everyone's going through the same thing, and you get access to a lot of like professional development events and a lot of social events as well, being part of that group. So I would recommend Alopecia. Galileo is the male part, and Hypatia is the female.
For engineering medical devices, is mechanical or biomedical engineering a better major?
Well, I'll give my perspective on this as the biomedical engineering chair, but I'll also let you hear from, I believe, 2 of our undergrads are mechanical, and actually, Riley, you are a BSc, is that correct? Awesome. Okay, so we have a lot of different perspectives here. So I would highly suggest taking a look at the specific curriculum. So looking at what an ME takes versus the BME takes at each of the schools that you're interested in. But particularly here at Tech, what you'll notice, our biomedical engineering program is new, but we have 21 technical elective credits, which means you get to pick essentially 7 classes to really specialize in what you would like to do. And we also have a lot of medical device oriented classes. So that really allows you to tailor to the specific kind of device that you want to be involved in as well. So if you're more interested in MRI or ultrasound or things along those lines, you can also take imaging and maybe some signal processing and other courses to really specialize within that area. I cannot speak to the mechanical engineering curriculum. I'll let my 2 mechanical engineer undergrads talk about it a little bit. But I would say that is a real strength for our BME program.
So I guess I'm a little impartial towards mechanical engineering because I'm in it. But I would say pick mechanical if you're still trying to leave the door open for other things, if you're still aren't sure. Because mechanical is a very flexible degree. You can do so much with it. Obviously, I took it to go into the biomedical route, but if you're still undecided, I would go mechanical. And mechanical is, you can just do a lot with it. And I was able to tailor my mechanical engineering degree by also doing a lot of minors. I'm doing a minor in biomedical engineering and in ESM. So it almost feels like I kind of did both. I would, if you're still trying to decide, I think mechanical is a really just a safe kind of option to go. And you obviously you'll learn a lot of the fundamentals. There are certain classes that you wouldn't take in BME, a lot of the heat and mass transfer, thermodynamics, stuff like that you would kind of only take in mechanical, but again, you can always do minors to supplement all of that.
I would also say, just from the engineering education department, that if you have any questions about any of the 14 majors, Virginia Tech has an incredible Explore Engineering website that you can literally Google just that, Explore Engineering VT, and it'll take you to a page that has every single major listed out, related minors, coursework, companies where students have interned in co-ops, professional societies, research, quite literally anything you might want to know about the different majors. That's an awesome place to start on really trying to figure out the specifics. But there are a ton of different ways to get to the exact same place. So I think it would really come down to what you are most interested in at the end of the day.
So when you think about leaving Virginia Tech, what is the thing you think besides food, don't give me food again, but what is the thing you think you will miss the most when you're done with your time at Virginia Tech?
I don't know. For me, I feel like the community, but I feel like the community also never goes away because no matter where I go in the world, I've also met Hokies. I've been in New Zealand on top of a mountain and met another person from Virginia Tech, and I was like, how did this happen? But it just kind of I think that'd be something I'll miss, but also never get away from is having this close knit of people around me that if I'm having trouble with a homework problem or having trouble with studying for certain tests, I just text one of my friends or just when I was in the dorms, you can just walk down the hallway and there's 50 engineers waiting to help you. Everyone's so helpful and just so tight knit. Everyone wants to succeed and everybody wants to help everyone succeed. So
yeah, I definitely echo that. Blacksburg feels Virginia Tech and Blacksburg it's very intertwined. You can't really tell the difference, where Virginia Tech ends and where Blacksburg begins. It's all the same. It's all just one big thing. And I would just miss the town in general. I just love going on walks, and there's so much to do, and there's so many beautiful hiking spots, and so you can always feel you have people to be around with, but at the same time you always have the opportunity of just going somewhere on your own and just exploring things. And it's also really, really safe. It's an extremely safe town. So I'll definitely miss that because I'm planning on going to a city and it's not the same.
I have a question for the group. what is your favorite part about working in the lab, and why would you recommend undergrad research to a prospective student?
Okay, I'll go. So when I first started, I started right away into like an independent study. But I know for a lot of our undergrads, like, they go into volunteer on other projects that are happening. But you do get to experience a lot of different projects. Like, once you're in the lab, you can always kind of try and tag along with one of the other grad students on their projects to see what's happening. So you get to see a lot of different aspects of biomechanics. But then you always kind of can go into like an opportunity of doing an independent study on your own, which is basically like kind of taking a project and completely being in charge of it. And I think that's really cool to do as an undergrad, to kind of take a project from start to finish. So that's something I would.
Yeah, I feel like I've learned like a lot of new skills just being in the lab that I wouldn't have learned just through my normal classes. There's like data processing stuff and different softwares that I've had crash courses on and learned a lot that I've been able to add to my resume. So I definitely think your skill set expands enormously when you actually participate in some type of research.
I think just always being interested in sports injuries, and like how they happen, and that eventually turning into, finding out about like how motion capture works, but never having any real experience with it. Once I started getting hands-on with that, using the motion capture system with the Qualisys software, and identifying all the markers and translating that to another software that actually exports the data, and just being able to quantify how people are moving, and seeing who's at risk with this type of movement. It's just been really cool to put it to numbers, because Dr. Queen, you guys have all heard me say it plenty of times. I'm a numbers guy, and it is just really cool, like taking these movements and being able to define them with numbers. So
I would say for me, like it's been great to be able to like have a place where I could find look more into biomechanics. 'Cause I knew I came into college like wanting to combine sports and engineering after growing up with sports, and also like being pretty good at math and science. And I was like, I'm gonna combine these somehow. And then like being in the lab has also allowed me, like when co-ops and stuff kind of became a little harder to find, or like internships for the summer became a little harder to find with COVID. This opened up a big door for me to get a lot of the experience that I wanted, but without having to take time off from school, or without having to like look, like, can't think of the right word for it, but it's like gave me an opportunity to be able to have these experiences. So it's been nice.
All right. Well, if you have any more questions, please check us out on our webpage. It is the granatalab.beam.bt.edu. And also, please be on the lookout. There's National Biomechanics Day starting April 7th. So we will have a lot of events in all the different biomechanics labs showcased starting then. Bye.